That means I'm gonna have to say something interesting, which is a lot of pressure. Any other introductions or interesting projects? We always like to hear if you've got cool projects you're doing or milestones that you want to talk about. Opportunities for collaboration. That's why we're here, is to mix and mingle, network a little bit. I'm gonna be at the Vertical Flight Society's Transformative Vertical Flight event in four weeks from now. So
the next one, which I think is really kind
hey,
of, oh boy, it's
hey Ron.
it's
Yeah, hi,
too
Andy.
big.
Hey, I think we can hear you.
And
Oh, okay. Let me take care of that.
yeah, and I'm wondering if we can do a face thing.
Hold on.
Because it there, and I can show you where it ends up on my face.
Okay. Hold on.
All right. So I was going to talk about events a little bit. We've got the Vertical Flight Society's eVTOL event coming up in Phoenix, first week of February. So that'll be a lot of fun. I'll be out there with Hector Shu, who's our CEO at Rotor. He's going to talk about what we've been up to, and I hope to see some of you out there as well. But that should be a great event, good networking opportunities. So if you will be out there, definitely shoot me an email, and let's get together for a coffee. Are there any events that you've been to lately or might have on your schedules that we should know about?
I have some small information. I will go next week to India. So it's a really interesting place with a lot of opportunities for this kind of vehicles. Flying taxi, it's still a big bubble there, not like in Europe now with Lilo and Volocopter falling. So it's at the end of the next week, it will be like flying taxi event. And in February, I also will go to the Air India in Bangalore. So
Oh, excellent.
But it's India really really interesting country, and it's I found a really nice insights about the Indian startup time, where everyone promised you everything and it's not happened all the
time. Well, I'm glad you're going. I went for 2 weeks to India in 2005, 20 years ago, and I've got to imagine it would be completely unrecognizable at this point. But Val, I'm glad you're going, and to the extent that you're interested and comfortable, take some pictures and notes, and give us a event report next time. We'd love to hear about that. That's going to be that's going to be a big one. Yeah, that'd be great. Hey, Brandon, great to see you.
Yeah, great to see you. India tweaked me as well. We have JetSet Go as a partner, regional operator out there, helicopters and fixed wing folks. And specifically, it's interesting because there's a lot of subsidies in developing the northeastern region, which is challenging from a VTOL perspective because of the altitudes involved in some of the weather patterns and the sparse sort of geographies out there. So we have developed a pretty cool software tool that has all of our performance parameters in it, with some conservative estimates and fuel burns and mission profiles and all that sort of stuff. And with various payloads and ranges, it automatically pings and can connect different regional routes that may be actually profitable based on certain economics. You input sort of a sophisticated cost model that was developed by our CFO, and he comes from a company that had multiple helicopter operations. And it's pretty interesting when you input the numbers and you're realistic about it. So that just tweaked me on that. It's a pretty interesting area with some tight economics, but a lot of government support for developing, especially that northeastern region. And you mentioned interesting activities. We're going to the Lessors Conference in Dublin. Now, everyone seems to be focused on all these VTOL conferences, and it's great, and we go to some of them, but the Lessor Conference is interesting. There are basically bankers there and lessors and some operators. And they ask a lot of really hard questions about the economics and durability of the aircraft, residual values, power by the hour type stuff. And they really focus and require you to dial in your economics and prove that your machine is going to be leasable within the construct of their tight parameters for profit. Because they look to target around a 20% profit on an annual basis, if you can believe that or not. So quite, I thought that's quite interesting anyway. Maybe something that that doesn't get talked about as much, those functional sort of conferences that sharpen up the economics behind some of these new offerings.
Yeah, I think
Brandon?
to Brandon on that, I've been at many iStats in the past, and a lot of people don't know, if you looked at them 30 years ago, they maybe owned 10, 15, 20% of a transport of major airlines aircraft. Right now, they're up to almost 50% plus of most airlines out there now owned by lessors out there, just for reference.
Yeah, absolutely.
I think, Brandon, I think it's brilliant to go in from that angle of let's step back to think about, okay, even before we've got this great product, what do we need to get lined up? And it's going to be financing, and it's also going to be insurance, right? A lessor is not going to want to do a thing until they've got insurance, and that's why we want to cozy up with our partners like Alistair Blundy and other companies that are willing to focus and give us attention in this space.
Yeah, and insurance is an interesting one because it's all about data. And so we're trying to partner with some major insurance companies right now because they have to get to know your machine. These are new architectures. They're not sure, and they're going to take a very conservative underwriting approach. And the more data and the more familiarity they can have with your machine and the flight test program that's been through, and I can't stress the importance of that enough. And again, I think there's a lot of companies in the space that are, taking a bit of if you build it, they will come approach. And I think the opposite approach, laser focused on the operators and ensuring product market fit with the parameters of your machine. And if it can't operate profitably and replace helicopters, for example, on certain routes, or and you're not realistic about battery replacement costs and all the maintenance aspects of it and residual values, they just won't buy it, right? And they'll end up being nice machines that go through flight test programs, but they won't get widely proliferated.
Yeah, and you'd mentioned sort of the data and the tracking. I know that's something that Danny Macco has been really focused on. Yep. It makes sense because we're talking about new types of aircraft that operate in novel ways that are going to require new types of pilot training. And we need to be tracking everything that's going on, from pilot input to control surfaces to the types of usage, landings, everything that all needs to get tracked. And I know Danny's been spending a lot of time paying attention to that. And that interfaces really well with insurers and owners and lessors, because they all want to know, how are these aircraft being used? Is it in the way that we envisioned? And if there's any opportunity for improvements in safety and operations, then we want to be able to track and take actionable take action on those.
Well said, Andy.
We touched on the VFS event next month, and we're lucky to have Mike Hirschberg with us. And Mike, tell us what we need to know about this event, because I know it's going to be a great one. I've been a couple of years in the past, and it's the best one of the year for me. What do we need to know?
Well, thanks, Andy. Much appreciated. Yeah, I mean, we're going to have I'll say the usual suspects of the major companies, FAA, folks talking about the regulations and autonomy, military applications. We'll have the Air Force Agility Prime again. So we got a great program set up. We moved to a much larger facility than we've had in the past because it had been too crowded. So there'll be plenty of elbow room, much more time for things like networking and for exhibit hall and such like that. So we made it. We've tailored to be less, I'll say, less cramped and more conducive to discussions. So anyway, hope everyone that's interested can register. I'll put the link in the chat. Still time to register and come and everything. I also want to mention, Andy, since you asked about upcoming events. So we have our annual hydrogen symposium. It'll be at the beginning of April in Long Beach. So that's always a good event, and we've got an all-star cast lined up to speak there as well. So yeah, just great discussion here from you guys. I'm glad to be able to call in, and you know, hats off again to you, Andy, for all you do for the AAM community.
Happy to do it. Happy to do it. It's a lot of fun. I was telling Darrell before we got started, in this space right now, it's holding on to the tiger's tail. You gotta pay attention because things are changing second to second. And VFS is the best way to stay on top of everything that's going on and to network and build relationships. And Mike, you had mentioned AFWERX Agility Prime. That's a great funding mechanism for startups, and there's a lot of opportunities out there in terms of SBIRs and SITRs. That's funding that comes from the U.S. government for U.S. companies, where Congress says, look, we're going to give you, Air Force, X billions of dollars. You need to give a small percentage of that out to startup companies to help in the United States, to help them get going. You can do that through the Small Business Administration. So there's these programs, SBIRs and SITRs, and that's what Agility Prime and AFWERX is about. But NASA and other government entities also have funding opportunities. And in fact, NASA only releases theirs once a year, and they just released all their opportunities on Tuesday. So if you're a startup in the space, jump on the NASA website and search for SBIR/STTRs. There's a couple documents you'll find. They're about, I sifted through them on Tuesday. They're almost 500 pages each. There's a lot there, but do your keyword searches and see what opportunities are there, and you find some interesting stuff. So I'm going to ask everybody to go ahead and mute, unless there's anybody else that has anything interesting going on. And Tony, I'm looking specifically at you. I know you're multitasking and clicking, but I wonder if you could mute as well. Let's see.
Sorry, Andy, I thought I was on mute all the time.
No worries. No worries. And before we get started with our speaker, anything else that we might have missed, or any other events, milestones, or things that we want to be aware of? All right,
then I may mention something. End of last year, suddenly from Next Partners, this Saudi Arabian event was brought up. I don't know if anybody else got this short notice invitation as well, that the Saudi government, together with the US Commercial Department, are organizing an event for eVTOL possibilities in Saudi Arabia. So
that's good.
Yeah,
they will even have a trade mission going over there early February,
right.
And then they will have a virtual event in that time frame as well.
Yeah, so that's something that one of our members, Nexa Capital, and also New Air are leading. So you guys should have seen the notices that we've been sending out about that, but I'll post it in the link in the chat as well. They're full for the in-person, but there still are opportunities for virtual. So I think it's something highly recommended.
Yeah, and I just wanted to put that in the group chat. This is a new advanced aerial mobility consortium formed in India. So people who are talking about India interest in that, keep that on their radar. It's on the group chat.
Fantastic. Fantastic. No, we're talking to an Indian partner as well, and I think all of us are. I mean, what are we talking about? 1.2 or 1.3 billion people, and in some cases,
All said
limited
and done, it'd
infrastructure.
be 1.5 billion by 2030, with incredible opportunities in India down the road, because just the infrastructure is very creaky and you need to get over that hurdle. And the only way to do that is to get into the third dimension. And the Indians are thinking really seriously and stuff. I spoke to the new civil aviation minister. He comes from my home territory, so to speak, previous.
Yeah. Yeah.
So, there may be making some good news soon.
Oh, I am very excited about what's going to happen in India. It's I really feel like it's going to be just what happened with cell phones. They're growing so fast. They're skipping whole generations of technologies.
Yes. Yep.
So they're just going to go right to current and skip the previous 2 or 3, which is fantastic.
And what's happening in the Middle East too? I'm excited about Dubai, Abu Dhabi, and Saudi and stuff. And February 17th is when this delegation from the US is coming here. So I know a few people who are coming.
Outstanding. Good. No, that's great. We need to stay in touch with what's going on in India and Saudi and everywhere.
There is another example about India. So right now they try to find some possible solution for 300 kg payload drone, which can fly up to 6,000 meters high, because they need to supply border control stations and some in the Himalaya mountains. And right now it's supplied by the mules in 2 weeks.
That's what I'm talking about. They're going to skip 3 generations of technology. Mule to advanced air mobility aircraft. That's super cool. Love it. All right. Well, listen, this is a good time for us to introduce our speaker. So I'll ask everybody that hasn't already to go ahead and mute, and I'll do the same in a second. I'm going to introduce Darrell Swanson and Jarek Zych from EAMaven, and I've had the real pleasure of working with Darrell in the past. He's been very active with Vertical Flight Society, including being one of the working group leaders long before I was within Vertical Flight Society. And he and Jarek have gotten so busy since then that they've started EAMaven a couple of years ago, although they've been in the consulting in this space for years before that. Darrell's been traveling the world. I'll occasionally hear he's this or the other place on the end of the planet going to speak to people, but he and Jarek have been aggregating a lot of data and doing a lot of analysis, and they brought, I think, a little bit of it to share with us today. And the reason why they're gathering all this information is that's what they do at their company. So I'm just looking at the sort of the breadth of services that they offer. They do advanced air mobility modeling, scheduling, service development, market assessment, infrastructure, vertiports, carbon emission savings, revenue forecasting. They take all the data and model everything and then put it in a nice, neat package with a bow on it so that we can make it into actionable information. I've seen some of Darrell's work in the past. It's always very insightful and interesting to me. And so I was very excited that Darrell Swanson and Jarek Zych with EAMaven were willing and interested to present to us today. And so with that, Darrell, I'll give you and Jarek the floor. Tell us what you've been up to.
Brilliant. Thank you very much for that, Andy. And as I said before, I do feel bad. I've kind of had to step away from the VFS, just that Jarek and I have been getting really busy, but it's always great to get all the updates of what's happening. So EAMaven, we're about 2 years old. We're a management consultancy, so we're kind of like McKinsey, but more affordable. And basically, we set up the company because we got sick and tired of the Morgan Stanleys and McKinsey saying that advanced air mobility is going to be worth millions, billions, and trillions by X whatever year, when in fact it's written by graduate consultants of the company. No doubt they're smart people, but they have zero experience in the commercial aviation industry. And that's really our background. So we decided that we actually need to do something. So what they do is top-down econometric guessing. So they multiply averages together to come up with average numbers. What we do is very different. We do bottom-up route by route analysis to actually understand what the real potential is. And everything that we'll present to you is what the real potential for advanced air mobility is in the UK in the case studies that we're talking about. My background, I'm an airport planner by education, planning and designing airports around the world. Ran one in Tanzania, which was good fun, and then started doing a lot of acquisition due diligence on the capital investment side. So basically, Jarek and I, we worked for the same company for a while. We know what goes into an information package to go to help somebody buy an airport. So we know the level of diligence that you need to get into it, which is why you can't take a Morgan Stanley report to a bank and expect to get funding. So you need to do the detail. So that's my bit of the company. EAMaven, yes, that's exactly it. Take a look at the website and what we do, but a lot of what we do is demand modeling, system planning, forecasting, and then we advise on infrastructure for advanced air mobility. So that's a little bit about me. I'll let Jarek introduce himself and tell you about what he does with EAMaven.
Hello, everyone. My name is Jarek Zych, and as Darrell mentioned, I'm also a co-founder of EAMaven. So my main area of expertise is actually traditional aviation, or coming from traditional aviation. My main area of expertise actually is service development for airlines and airports, traffic forecasting, scheduling, network planning, and business planning for airlines and airports. So I used to work for an airport in Europe for a couple of years, working on their basically network and air service development. Then moved to the UK, met Darrell, and was working for this consulting company when we were working together on this traffic forecasting and air service development initiatives. So Darrell was responsible for the infrastructure side. I was responsible for the traffic side. And after a couple of years working together, we just decided to move on and focus on this electric and hybrid novel aircraft in aviation. So basically, we used our expertise and knowledge to build models that could reflect novel propulsion systems, novel aircraft, and basically this all electric aircraft that are being built now. So that's in a nutshell about me.
Really? Okay, I'm going to try and share my screen. And hopefully you are seeing something that looks like fireworks.
We do.
Right, okay, so this is us. That's actually a screenshot of the north of the UK and the potential advanced air mobility routes across the UK. So deliberately hiding some stuff, but that's who we are. So EAMaven, Electric Aviation Maven, EAMaven.com. You'll find probably a lot of this information there, but we'll make sure that you guys get a copy of this deck at the end of it. So what we're going to talk about today is the advanced air mobility opportunity for the United Kingdom, because we have a data set that covers the entire United Kingdom, and this is all based on mobile phone data, which is the new source of truth for aviation, and we see it as something that is going to be transformational in the aviation industry. It's this data becomes more available and more affordable. It's blindingly expensive, but you can do a lot with it when you get in there. So I'm going to hand it over to Jarek, and he's going to take you through a review of our methodology, which really will help you understand why this is bottom-up forecasting, not top-down econometric guessing. There's a lot of real data that goes into this. So Jarek, please, I'll run the deck and you talk.
So I think the main takeaway here is that, as Darrell mentioned, it's not top-down econometric guessing. What we do is actually proper bottom-up approach. So basically, we analyzed, for this particular example, the UK route by route. So when we first started working on this, we were wondering what kind of data sets would be the best to basically describe how the situation looks like. And there is a lot of OAGs or Sabres of the world out there, but they don't actually show the detailed picture. There's only the big picture, traditional aviation services that are operated already, but we actually don't know how people travel and where people travel, especially domestically. So what we thought we could try with mobility data, so basically apps data and mobile phone data, because that reflects true origin and destination and true traffic flows within each country or cross country as well, if you have enough data. And basically what's special about it is basically got embedded information of people's choice. So basically we have insights into how people travel. So basically what modes of transport like cars or rail, on what purposes they travel, so business, leisure passengers or commuters. And also we have insights into time of day or day of week. So we have basically patterns for each of those routes. So what we built is actually like a three-layer approach. So first layer is what we call indexing, which basically we analyzed the data set that we have for the country, so in this case UK. And just to give you an overview, we have granularity of 400 shapes, which are shapes based on governmental shaping code LAW1, Local Administrative Units 1. And what we've analyzed is basically identified all within those 400 shapes, all the airports and all population centers, and measured all traffic flows on a weekly basis between those places. So we have insights into 400, almost 400, because London consists of 36 shapes, 400, almost 400 population centers, and all commercial airports and some smaller airports as well within the UK. And what we've analyzed, we basically analyzed all the possible routings there. And through some various weighting factors and using some coefficients, and then basically what we call indexing, we've come up with a list of or the ranking of routes that would be most viable for future RAM operations based on several factors like frequencies, time of travel, fares, and convenience of travel, for example. So this is the first layer of our analysis, indexing. Once we have this list, we can do a detailed demand modeling on each route. So basically, we built a demand model which is trying to predict how many people switch from other modes of transport like cars and rail based on certain criteria, like I mentioned, travel time, convenience, fares offering, and other factors that we use. So once we have that, we can predict how many people would switch to new RAM and UAM operations based on a number of frequencies the new service would be offering on each route. So this is like our second layer of analysis. This is the great information. This already gives you a lot of insights, but it's not a full picture. For example, for an OEM or owner operator, you would like to know what would be your network for a future operation, what would be your utilization per aircraft, how many aircraft you would need, what load factors would be. So this is what we call the third layer of our operations or analysis. And so we have linked schedules. So we use the demand modeling data and we put it in our scheduling tool. And basically the scheduling tool creates a network based on these certain criteria that we put. And we know out of that what optimal schedule would be, how many aircraft would be required, what the utilization would be, average fares, load factor. So everything that an operator or an OEM would like to know for their basically business planning and operations. So this is basically our complete three-layer type of analysis. Next slide, Darrell. Yeah, and here we just wanted to show you like a summary of our analysis for the UK. So this is just an overview on maps for UAM and RAM, so average length sectors for regional air mobility and urban air mobility, because we believe that UAM wouldn't be only for like small hops, like 5-mile hops, but we believe that that would be between 30 or 120 miles, depending on aircraft max range. And the average length of regional air mobility in the UK, based on this analysis that we've done for all the possible routes, is around 143 miles. And some more information about our findings. Our next slide, please. So this is just a summary of the total UK AAM potential, so RAM and UAM. So as I mentioned, we've analyzed all the commercial airports, so 63 airports under study, and we've analyzed and identified 684 routes for RAM and almost 1,000 routes for UAM out of 264 cities. So that's quite a comprehensive number. We've also analyzed the target market for both. So annually, we would have more than 400 million for RAM and more than 300 million for UAM. And we also have insights into, for example, how people travel, so what modes, as I mentioned. So interestingly, in the UK, more than 82% travel by car. So this is a significant number on those 684 routes identified for regional air mobility. And for the UAM, we have 75%, so it's quite a large number of people traveling by car between those places. So what we are trying to do with all those novel aircraft, we would like to basically take people out of the roads and start using more sustainable ways of travel. We have also insights into purposes of travel, and interestingly, it's quite high in terms of business travelers, more than 20% for RAM and more than 33% for UAM. So we believe those will be the first people that could use the service. So those routes with high business traffic would be those that we would probably analyze at first. Darrell, you want to continue about the hour safe?
Yeah.
And, yeah.
Yeah. So basically, what we're able to do is calculate the time saved over other modes of transport. So if you were to drive from A to B, or take a train, or if you were to fly, we can calculate the difference there. And that's actually a time savings, and that has an economic impact. So for regional air mobility, we're saving 47 million hours on an annualized basis, all those people that would switch. So that's about 5,400 years of time that could be put back into economic productivity. Sorry, I'm seeing Michael putting up a comment there about Uber Elevate. Yeah, they did use mobile data, but it was all based on a lot of their journeys. The data that we're using covers an entire country or region, so it's a lot better in terms of a data set. But we're also using data from apps as well, which is a lot more insightful into that. But yeah, we'll come to that in a second. So back to this the data here. So 47 million hours saved for regional air mobility and 27 million hours used saved for urban air mobility, and that has an economic impact. So we use some data from the government, and that suggests that we could put about 1.1 billion back into the economy just through the value of the time saved for regional air mobility. And about 615 million for urban air mobility. So we're about 1.7 billion that could go back into the economy if all of these routes were realized. And obviously, we don't see it all being realized tomorrow. This will take time, but these are the kind of numbers that government need to be able to make decisions on how much they want to support advanced air mobility. So in terms of what that actually means, so for regional air mobility, we need about 1,500 aircraft or 2,200 eVTOLs. For vertiports, we need about 905 stands. So this is where my airport planning kind of comes into it. And then we would need 314 vertiports to service that demand. We have different ways of calculating carbon emission savings. So we can calculate the average emissions per mile for surface transport, road and rail. And then we can actually take a look at various different benchmarks that we have from agreements that we have with OEMs in the space about how much carbon emissions could be saved. So if it was 100% SAF, then we could save about 214,000 tons of carbon emissions. If it was hydrogen aircraft, 120,000 tons of carbon emission savings could potentially be saved. On UAM, because it's all electric, it's a little bit easier to measure. We're looking at about 178,000 tons of carbon emissions savings for those types of operations. Now, this is where the fun part starts because we've been able to calculate the amount of energy required. So if all those routes, those 1,500 aircraft were powered by hydrogen in the UK, we need 52 million kilograms of gaseous hydrogen, compressed gaseous hydrogen. But we need 2.7 terawatt hours of power to produce that. And if anybody knows anything about the UK grid, it can't handle that. It couldn't even handle the 850 gigawatt hours of power for UAM. So we have a real energy problem. So this is stuff that we've been talking to the grid about, other players, government, trying to get them to understand that they need to come up with an energy strategy to enable this, because of course we're competing with data centers, we're competing with EVs on the road for power. Everybody's trying to go to electric, so there's going to be a big crunch in that space. So basically, I can't do it, Captain. I haven't got the power, and that's going to be something that you're going to be seeing a lot of in the near future. Jarek, do you want to take them through the revenue opportunities?
Sure. So based on the analysis that we mentioned here, we also can assess basically what the fares would be, or what an average fare would be for RAM and UAM. And what we do, we compare fares or basically cost of travel on other modes of transport, like for example, tickets for economy or first class rail, or cost of travel owing by or traveling by car or owning a car. So it's not like just fuel price, but also all the costs that basically is once you buy a car, and basically your maintenance, insurance, etc., and amortization. So basically, this is based on comparative analysis and some information from OEMs on their cost of travel, basically correlated with some data sets from traditional aviation. So out of that, we can assess what future revenues for future RAM operators would be based on those assumed networks and routes, so ND routes. And we also try to measure ticket sales for the operator, but also airport revenues. So basically how much you could get from your passenger fares or passenger how much people pay for their passengers at the airport, for example, ground handling as well, and landing charges. So all charges that airport operators could charge. And these are just basically the summary of the analysis on the UAM and RAM side.
So it's a lot of money there. So we're looking at least $7+ billion that could go into the economy for that. So this is just a bit of a summary in terms of UAM or RAM, which is going to be more economically significant. And at EAMaven, our opinion is that globally, regional air mobility will be a bigger market than urban air mobility. Now, we're not saying that urban air mobility isn't going to be a market. It is going to be a massive market. But we just think that on balance, the utility that's offered to the passenger through regional air mobility, because you're saving them that much more time over surface modes of transport that they would have to take, is just going to mean that it's going to be more tempting for them to get into one of these aircraft. Now, of course, we still have a lot of problems to solve. First mile, last mile, it's usually the big thing that people focus on. But on balance, we think that that's where there's going to be a lot of attractiveness, and it could have big implications to the way the airport systems are operated. It could have a big impact on the commuter airlines out there. There's predictions out there that this could be the killer for commuter airlines because of their low utilization and low profitability, unless you're really, really good. So yeah, it's a very interesting space at the moment. But again, we got to watch out for the power question. The big number is that RAM is 3 times bigger than UAM in terms of the number of potential routes, and 8 times bigger in terms of the economic impact. And this is across the UK, but we've done this in the Republic of Ireland, and we'll show you a summary of that number in a minute. Jarek, do you want to take them through this? Because this is a nice, interesting piece of analysis that we've just recently done.
Yeah, so this is actually a chart showing what kind of aircraft are actually used or being used now on all UK domestic routes. So basically, we are trying to understand what density of aircraft is used for each operation based on their average sector length, and how many routes that we identified for RAM would basically could be operated by those aircraft based on certain criteria. So of course, as you can see, those highlighted in white, this white circle, are those that are probably the most viable in terms of seating density for future RAM operations. So almost all the routes could be operated on a 9-seater or 18-seater. Because there seem to be the most viable aircraft in terms of seating density, and what translates into, of course, frequency offering and healthy load factors. So the more density on the aircraft is probably fewer routes that could be operated in terms of their viability. So we basically correlated all the main metrics that you could basically analyze when assessing the route viability. So basically load factors, achievable revenues, most suitable frequencies to basically offer like a flexible schedule for passengers, and how it translates into this market share based on an aircraft type. So what we believe probably the perfect sweet spot is between 9 and 18 seats for those kind of operations. And interestingly, most of those aircraft being used now on the UK domestic routes are very, very large aircraft like 737s or Embraer's 195s, and they usually, of course, are used for feeder traffic to larger international flights, because this is a bit different type of operations, not entirely RAM, but it's nevertheless interesting to see how it looks like.
Right. So what we've done, and we'll go through this quickly. So obviously what we showed you was what the total potential is based on our analysis technique and all 684 potential routes for regional air mobility and 994 for urban air mobility. So we've gone back and we've done a cut of it based on what we think is the number of aircraft that OEMs can put into the space. So the number of aircraft that a fixed wing operator could put into the space, or sorry, fixed wing OEM could put into the space, or an eVTOL OEM based on their production capacities or their publicly stated. And as it turned out, it's somewhere around 10%. It wasn't 10% driving it. It was actually what the OEMs could actually do. So same numbers are coming up, or the same format. And again, we'll make sure you guys get a copy of this. So 23 airports having a potential of 70 routes, or 82 cities or population centers with 105 potential routes. And you see the numbers coming through here. Economic stimulation, hours saved, the split between leisure and travel, and the mode of transport. And here we get into the number of aircraft. So 193 aircraft for RAM, 356 UAM aircraft, and then we have the numbers in terms of vertiports and stands to enable that system. Potential capital cost, of course, because that's what I used to do. So that was relatively straightforward to come up with. And then the carbon emission saving numbers that could be achieved through switching people onto advanced air mobility modes of transport. And in terms of energy, much more reasonable numbers. If 361 gigawatt hours is reasonable, plus another 177 gigawatt hours for UAM. Now, of course, obviously the UAM bit is a bit more challenging, because that's where power is least available in the city centers. So again, there's going to be a real bottleneck for energy. Just a map there in terms of where the power is required for UAM or the carbon emission savings. So we do a lot of this stuff, and I think the interesting stuff is that Jarek is developing a dashboard for this. So if you become a commercial client of us, you'll have access to a dashboard which is interactive. All the maps and charts and your ability to really dive into the data will be there. But Jarek is still learning Python, or he's playing with it. Thankfully, better him than me. Revenue side, in terms of regional air mobility, so 300 million for the RAM operators and 500 million for UAM, 76 million for the operators of the airports, and then we have the revenue there for the vertiports operators. So it's just additional real data that can go into the system to help people actually come up with their business plans. This is the breakdown in terms of the RAM potential. So it's 7 operators across 15 hubs, 105 routes. And then you see there where we're breaking down the aircraft and the number of pilots. Pilots are going to be a real challenge in terms of getting them out there. That maintenance side, that looks a little bit light, but there's an assumption in there that a lot of the maintenance will be sub-consulted or subbed out to an MRO company. The landings, the passenger numbers, and then the revenue numbers. And just to let you know, we're working with Flyv, which is a startup operator out of Germany. They're going to initially be starting with Tecnam P2012s, and it's a lovely little aircraft, fantastic operating costs, great range, reasonable speed, and it's one of those aircraft that you can operate now on these routes to get you into it whilst you're waiting for Electra or eViation or Hart Aerospace to get their aircraft up and running in volume. We've done the same for urban air mobility, so the same numbers, same split, but again, 1,425 pilots. So companies that are out there in the training space, big opportunities for them to leverage that. So that's basically it for the UK. We've also done this for the Republic of Ireland. I'll let Jarek talk you through this, but basically we're still getting the same type of message in that regional air mobility is going to be a much bigger market. And we've done some work in Spain, and like I said, we're about to get access to a global data set. We'll start with Europe first and index it, and then move on to North America and then Southeast Asia. So Jarek.
So the methodology is very similar to the one of the UK. So we've also analyzed those cities and airports based on a certain spatial division for the Irish data set that we had. And of course, the number of routes and the number of shapes is different because that's a much smaller country, but we've analyzed and come up with a list of 174 routes for AAM, so UAM, and the same amount of routes for RAM. So basically, we've analyzed all the potential or all the commercial airports in Ireland, and come up with the possible number of routes between those. And of course, it's a very Dublin centric. As you can see here, we've analyzed 123 cities and 16 airports, and out of that, we've come up with a number of routes as well. So this is just an overview of the analysis. And basically the executive summary of our UAM city index. So in terms of passengers and total addressable market, it's still quite significant, around 130.7 million annually. And the same breakdown in terms of modes of transport and places of travel. So as you can see, in Ireland, there's a lot of majority of people travel by car as well. It's even more than in the UK, 87%. We have some insights into foreign travelers as well. So we know basically because of this roaming devices, basically we can derive data. So what's domestic and what's international in terms of mobile phones. So we know the nationality of travelers and how they travel. So that's quite interesting as well. In terms of like the narrowing down the routes, out of 4.7 thousand routes analyzed, we've narrowed it down to 174. So you can see it's a lot of routes at the beginning, and through our indexing process, we've narrowed them down to 174 and 103 cities under study. And the same metrics for modes of transport purposes of travel. We also measured time savings, so basically how much time and how it would translate into economic boost for those that could switch from cars and rail. So as you can see, we could have around 100 million euros per year on all those routes if those people would switch to novel aircraft type. We do some regional breakdowns as well, so you can see on the UAM city index, there's a lot of Dublin-centric to other places. And the total target market is almost 90 million per month, per year, and almost 100 million in terms of economic boost. And we did the same for regional air mobility. So basically, this is just a map of all airports, commercial airports identified, and how many routes we've identified that could be most viable for future RAM operations. And this is 50 of them. And so basically we've analyzed all the catchment areas around the airports and analyzed how people travel between those catchment areas. So it's not like airport to airport, it's basically catchment area to catchment area. And out of that, we've identified almost 80 million travelers annually. And out of those 80 million, through demand modeling, we could actually know how many people would actually switch based on certain criteria. But doing some regression analysis, so high-level analysis, we could basically assess how much time would be safe and what the economic boost would be for those people that's switching on all those 50 routes. So in terms of RAM, it's much more, it's almost 200 million, and that's mainly because when you fly longer distances, you save more time, because getting from A to B basically service modes of transport, when it's a long distance, it's much more time consuming. Yeah,
so
that's about it.
Yeah, brilliant. Thank you very much.
Thank you.
Just brilliant. I know that's just a small taste of what it is that you guys do, but that is fascinating information. And there's some real telling things there in terms of how many pilots we're going to need and how much power we're going to need. We're going to be sucking up a lot of resources that might not be there, and everyone needs to know that we got to staff up and power up.
Yeah, exactly. We're hopeful that these small modular reactors are going to start to come online as they become licensed. So we're definitely watching that space. We also think that regional airports have a real opportunity to become energy hubs of the future, either where they'll be putting in storage or production of electricity through sustainable methods, or getting electricity from the grid and storing it, producing hydrogen for those aircraft that are going to be needed. So yeah, there's huge opportunities in that space. There's going to be a lot of work needed at airports as well to make them suitable. Obviously, just putting in the recharging facility or the hydrogen facilities. But you also have to take a look at the terminal building. Is it fit for purpose for the number of passengers that we're predicting? So there will be investment that's required, but that's actually the space that we come from. So we know what that investment looks like, and we know how to get that financed through providing this kind of analysis. Just to some of the earlier conversations, the leasing conference in Ireland, very good one to go to. We helped Avalon E. We helped Vertical Aerospace sell 500 aircraft to Avalon E through this type of analysis. And so that's coming home to roost in that some of those people are reaching out to us to do detailed demand modeling for the routes that they're trying to build and the schedules and sectors. So yeah, it's a very interesting space, but we're convinced that this kind of analysis is what is needed to enable the investment, because otherwise it is just top-down econometric guessing, and they'll say, no, that doesn't stack up. Go back and try again.
Yeah. Well, I've done you a real disservice by not giving you enough time for Q&A, because we're at the end of our hour, and I'm looking at the notes, and you're getting just tremendous response. Great follow-up questions and really positive response at the data that you've shared with us. So to make up for it, I'd like to offer for you guys to come back anytime you want to this year. Give us an update and continue to tease us with the information that you can provide, because this is very, very useful for all of us as we think about how to substantiate the work that we're doing and the direction that we want to go in. This is real, true data-based information that we can use to make important investment plans.
Yeah. Is there any way of capturing all the questions and then we can fire back some Q&A in that? We'll put some stuff out there. But by all means, if anybody's wants to reach out to us, you can contact us either via LinkedIn or our email addresses. I'm sure, Andy, you can share that around with everybody.
Absolutely.
We'll send you a copy of the deck, which has our contact details.
I don't know if it's just me that can see it, but when I go to the chat and I go to the three dots in the upper right, there's it opens up a box that says Save Chat.
Okay, let me do that.
And so I just click that, and I think it creates a text file somewhere in our downloads where then we can see those. But there, you got some good ones there, and you got some very positive response that I wanted to make sure you saw. So thank you for doing this.
Yeah, we'll absolutely we'll respond to those. I've got them. There we go.
And we'll see you at some events out there. Look forward to seeing more of your work. And like I say, open door to come back anytime. This was fantastic, and I know we all really enjoyed it. I certainly did.
Great. Thank you very much.
Great work, gents. I know this wasn't easy.
Thank you.
Great job.
Thank you.
Cheers, everybody.
Everyone, thanks for being here. And I'm always looking for presenters. So if you've got a product or service, talk to me. Let's get you on the roster.
Thanks.
Take care,
It was a
everyone.
great presentation.
Thanks again,
Thank you.
Andy.
Cheers,
Great
guys.
meeting.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you also. Thank you.